Welcome to the Virtual Pathfinder channel. This is the second video in a series of videos about portable astrophotography rigs. I have been talking about my definition of ultralight equipment in a previous video. Now is the time to get into the details. Here are the contents of this video. Before we move on, please remember to subscribe to this channel. I will start by giving a background to the ultralight equipment, the size and weight of it. Then I will talk a bit about the backpack I've used and the tripod, the star tracker, the optics and the camera. I will give some advice how to stabilize the rig. Then I will do a packing to see if all the parts fit inside the backpack. I will then have a look at the total size and weight of the equipment. And finally, I will have a look at the performance of this rig using a star tracker. I will also have a look at the performance of this rig without a star tracker. The ultralight rig is a setup for a weekend trip or to be carried in a backpack when hiking in the mountains. It should be easily carried on board an airplane as cabin luggage. At the same time, it should be capable of advanced astrophotography using a star tracker. At the end of this video, I will also have a look at what can be done without a star tracker for people who want to bring down the weight further or for those who have not yet decided to spend money on a star tracker. Using just a camera is a good way to get started and to find out if this kind of photography is interesting. All you need is a camera with manual setting of shutter speed. The goal is to find a rig which can perform all kinds of astrophotography, both planetary as well as deep sky, long exposure photography. It includes the camera, optics, star tracker and tripod, as well as all accessories needed. The definition of ultralight in this video is based on the size and weight allowed by the smallest cabin luggage when flying with low-price airlines. That means the total rig, including all parts, should be about 4 kilograms. And it should fit in a backpack with a size 20 x 25 x 40 centimeters. That makes it possible to travel with the cheapest airline tickets, which only include a small cabin bag that fits under the seat. This compact format also makes it easy to carry the equipment to remote locations with good viewing conditions. The backpack I use is an Amazon backpack for photo equipment, which is soft and can be squeezed a little to be exactly the size required. The dimensions are about 20 x 30 x 37 centimeters, which is a few centimeters wider than required, but since it is soft it can be squeezed to fulfill the maximum size requirement, 20 x 25 x 40 centimeters. Since the backpack is very small, there are hardly any ordinary tripods that meet the requirements. One option that actually works, which can carry the load of a star tracker and a camera, is the Joby GorillaPod 5K. This flexible tripod can carry up to 5 kilogram equipment. It can be placed on the ground, on a table or wrapped around steady objects such as fences and rails. The drawback is that it has very short legs and is therefore very low, just about 30 centimeters high. The weight is 470 grams, which is very light. The low tripod height limits the size and weight of the camera and the optics attached to it. The star tracker I use is a Vixen Polari, which weighs about 1 kilogram. The camera is a Micro Four Thirds Olympus OMD EM5, which weighs about 430 grams. Since the rig is quite low, the easiest way to make polar alignment is to have a tilt head tilted at the same angle as the latitude of the location where the imaging is performed. Then it is possible to use the built-in compass of the star tracker just to rotate the star tracker horizontally towards the north magnetic pole or the south magnetic pole if you are in the southern hemisphere. To do that, it is important to make sure the tripod head spirit level indicates a perfectly horizontal position. This alignment method is not precise, but considering the limited performance of the equipment, so there may not be a need for a precision polar alignment. That is important for advanced rigs using telescopes. Although the tripod can carry the weight of the star tracker and camera with optics, it is not possible to use counterweights. For that reason, the optics has to weigh less than 1 kilogram, and it cannot be too big since the tripod is quite low. In other words, most telescopes are not possible to use with this setup. The only telescope I found can be held steadily is the beginner telescope Celestron Travelscope 70, which weighs only about 700 grams. That is not an optimal telescope for deep sky or planets due to chromatic aberration, but it can do fairly well when imaging the moon. However, although it's within the weight limit, the Travelscope 70 is too big to fit the size requirements. There is not enough space for it in the backpack I use. A better option is to use bright wide-angle lenses, which can capture a wide area of the night sky. In this case, I use a Samyang 12mm f2 lens on a Micro Four Thirds camera. It weighs only about 300 grams. It can easily be attached to the star tracker. The rig weight then becomes about 2.7 kilograms. But when doing deep sky imaging, it is necessary to have a finder scope attached, and for that reason I have added a dovetailed rail with the finder scope to the rig, and the total weight including these parts becomes 3.1 kilograms. Another option, mainly for brighter objects, is to use telephoto lenses, especially compact mirror lenses, which can image bright deep sky objects, planets and the moon. I use Tokina 300mm f6.3, which is a relatively sharp and bright lens. At the same time, as it is very compact and lightweight, it weighs just under 300 grams and it's only about 5 centimeters in length. The total weight of the rig using this lens is 3.2 kilograms, including the finder scope. An alternative to the Tokina 300mm lens is the Tokina 400mm mirror lens, which is slightly heavier at 524 grams. I have tried it for a while and I will get back to it in another video. It has some advantages and drawbacks, for instance the light gathering capacity and the additional weight, but it is still within the requirements for the ultralight equipment. The lens aperture is about 60 mm, which limits the optical resolution, for instance when imaging small details on planets or the moon. The good thing about these camera lenses is that they can be used for ordinary photography daytime as well. The wide-angle lens can be used for landscape photography and the telephoto lenses can be used for wildlife photography. If possible, it's a good idea to stabilize the tripod since it's very lightweight. That can be done by either attaching some weight at the bottom of the legs or attaching them to the ground. Here I demonstrate one way of doing it using an elastic strap and a 2 kilo weight. When traveling, this weight can be replaced by, for instance, a 2-liter bottle of mineral water. This rig is not unstable without the extra weight, but for long exposures there is a point to make sure that the rig is fixed. Here I pack the disassembled rig, including all accessories, such as batteries and chargers, which have a total weight of about 464 grams. I also include two zoom lenses for ordinary daytime photography, a 14 to 42mm and a 45 to 150mm zoom lens. The total weight for these two lenses is 354 grams. For astrophotography, I packed a Samyang 12mm f2 lens and a Tokina 300mm f6.3 telephoto lens. As you can see, the backpack got almost completely full, but there's a little room for a toothbrush and with some effort maybe a pair of socks and a t-shirt. A photography enthusiast may not need much more than that. The total weight of the equipment, including backpack, two zoom lenses, a wide angle and a telephoto lens, is 5.2 kilograms. That is well within the cabin luggage limit, and although it's possible to add more personal items within the weight limit, there is very limited space to add things in this backpack. There is a point to include an iPad for image processing. I use an alternative to Photoshop called Affinity Photo, which allows me to stack lots of images manually on the iPad. With that app I can also do advanced post-processing of all images, including daytime photos. When adding the iPad with a small padded bag, the total weight of the backpack becomes 5.9 kilograms. Here are some sample images shot with Tokina mirror lenses with 300mm and 400mm focal length. I will not go into detail the comparison between these two lenses, that will require a separate video. What I can say is that the 300mm f6.3 lens is surprisingly good. It is especially designed for micro four thirds cameras and it is therefore extremely small and lightweight, just under 300 grams. As a low-budget version or a lightweight setup, we can use the rig without a star tracker. That saves about $400 or euros, and it reduces the weight with about 1.5 kilograms. When imaging without star tracker, there is a maximum exposure time up to which images can remain sharp without star trails. A simple rule of thumb is the so-called 500 rule, which is for full-frame cameras. It states that the maximum exposure time to achieve sharp images can be calculated by dividing 500 with the focal length of the lens. For instance, I used a wide-angle lens with focal length 12 mm, for which the rule states that the maximum exposure length is 500 divided by 12, which is 41.7 seconds for a full-frame camera. Since I used a Micro Four Thirds camera with crop factor 2, the maximum exposure time is half of what the 500 rule states, which is about 20 seconds. Therefore, the rule could be called the 250 rule for Micro Four Thirds cameras, since the calculation instead becomes 250 divided by the focal length, but it is known as the 500 rule. The problem with telephoto lenses is that they usually are not very bright with high f-numbers. Those are slow at gathering light and need long exposure times. At the same time, the 500 rule limits the exposure to short exposures, which becomes an impossible combination of requirements. Typical telephoto lenses can only be used for very bright objects when no star tracker is used. For instance, when I used a 300mm mirror lens to avoid motion blur, the longest exposure time is 0.8 seconds. Since the f-number for this lens is 6.3, faint objects cannot be imaged with that relatively short exposure time. For that reason, it is not possible to do deep sky imaging using telephoto lenses without star tracker. Without star tracker, it is not possible to do planetary imaging or detailed moon images either. Long focal length usually means less bright optics, and the 500 rule will not allow sufficiently long exposure to gather enough light. This setup works best when using relatively short focal lengths. When using the 500 rule, bright lenses with low f-numbers are useful since the exposure time is limited. The 500 rule also allows for longer exposure times for shorter focal lengths. Therefore, wide-angle lenses with wide aperture or low f-numbers are very useful. As mentioned, one example of such lens is the Samyang 12mm f2 wide-angle lens. With that lens, the camera can be attached to the GorillaPod 5K, which can be put on the ground or wrapped around a stable object such as rails and fences. The important thing is to make sure that it doesn't rotate when attached to these objects. It is very easy to use this setup. Just put it on the ground and aim at the target in the sky. Use the timer function to avoid shaking the camera when pressing the shutter button. Without the star tracker, the rig will weigh about 1 kilogram less than the complete rig, but there is an even more compact solution using a super clamp and a ball head instead of the tripod. To be able to use that setup, one will need something steady in the environment to attach the super clamp to. The super clamp can be folded and locked onto the back of the camera when it's carried around. The weight of the setup using the super clamp and the 12mm lens on a camera is just under 1 kilogram. Then there is also an even simpler solution, which is just to lay the camera on the ground and use a wide-angle lens and shoot straight up using a timer. That requires no tripod, but it has no flexibility at all. To be able to use any of these setups without star tracker, we need to adjust the shutter speed according to the 500 rule. Here are some images shot with a 12mm wide-angle lens without star tracker. These images are shot towards the northern sky a couple of weeks ago. If you look closer at them, we can see Mars, Jupiter, Ursa Minor and the bright star Capella. There are some thin clouds in some of the images. The second image shows the Big Dipper, where there's a bit of glow at the lower part in the northern sky, and I think it was Aurora Borealis, northern light, visible that evening. The conclusion is that a complete ultralight rig with star tracker can be packed in a small cabin bag, leaving room for perhaps only an extra t-shirt and a pair of socks and a toothbrush. It works for a short trip for a few days traveling by airplane. This rig can also easily be carried in a backpack to remote locations. The weight can be reduced further if the star tracker is excluded, but then the usage becomes more limited, mainly to wide-angle lenses, and telephoto lenses may be used only for very bright objects, mainly the moon. When using a star tracker, the center of mass is a bit high, and it's maybe a good idea to try to stabilize the rig, for instance by adding a payload at the bottom of the tripod legs. The weight of a complete ultralight rig with all parts including camera lenses, star tracker, tripod and backpack is between 4 and 6 kilograms. This rig with wide angle and telephoto lenses can perform all kinds of astrophotography of the moon, the planets and deep sky. A 6 kilogram packing includes an iPad for image processing as well. Without the star tracker, the rig becomes much lighter and is preferably used with a bright wide angle lens. The maximum exposure time is then calculated using the 500 rule. Regardless which rig is used, it is of course a good idea to take multiple photos and stack them to average out noise. In the next video I will have a look at a setup with a bigger and more stable tripod that fits inside a slightly bigger cabin luggage bag that fits in the overhead compartment. The slightly bigger cabin luggage usually means a bit more expensive airline tickets, but it's still not as expensive as the tickets with checked-in luggage. Although that is also a lightweight rig, it can carry a small refractor or catadioptric telescope with counterweight on a star tracker. In other words, it can do advanced astrophotography. The main compromise compared to a heavier setup is the stability. A heavier tripod can provide better stability, but a typical steady tripod will not fit inside a cabin luggage bag. But as I suggested for the small tripod in this video, that tripod can also be stabilized in various ways. But I will talk more about that in the next video. That was all for this time. Remember to subscribe to this channel so you don't miss the coming videos. Until then, have a nice day and many starry nights.